All right, so it says I can draw two linear equations and find the point of intersection. So we need to graph both lines and find the point of intersection. So first, when we do this, we want to make sure that we pick out the M and the B. It's always the first step. Pick out the M and the B. Okay? So I'm going to, M here is 2 over 1, and my B is negative 3. My M here is negative 3 over 1. My B is positive 2. Again, I'm just getting that from the equation. We already talked about picking out M and B. So I'm going to plot my B on my y-axis. Well, that's going to be at negative 3. From there, I'm going to go up 1, 2, and right 1. 1, 2 boxes, right 1 box. Up 2 boxes, right 1 box. Up 2 boxes, right 1 box. Okay? For this one, I'm going to plot my B at positive 2. I'm going to go down 1, 2, 3 boxes and right 1. Down 1, 2, 3 boxes and right 1. Okay? So what is the point of intersection? Positive 1, negative 1. Positive 1, negative 1. Okay? So looking at the second one, same thing. I'm going to plot my M and my B. Sorry, not plot my M and my B. I'm going to figure out what my M and my B are. All right, for this one, the number next to X is 4/3. The B is negative 3. There is no number next to X, so it is 0. And my B is 1. Remember, if it's just Y or X equals a number, you are going to find that number on that particular axis. So in this case, I would find 1 on the y-axis, and I would draw a horizontal line. If it was on the x-axis, it would be a vertical line. Okay? For the second one, or the first one in this case, sorry, I'm going to find negative 3, and I'm going to go up 1, 2, 3, 4, over 1, 2, and 3. Up 1, 2, 3, 4, right 1, 2, that's off the graph. Okay? So the point of intersection is here, and that point is 3, 1. That point is 3, 1. All right? For the next two, we gotta do a little bit of work for them. So I'm gonna write it here. X plus 3y equals negative 12. I first need to get y to be by itself. So the first thing standing in my way is the x, so I need to subtract x on both sides. That leaves me with a positive 3y equals, I have a negative x and a minus 12. Now I need to divide every single term by 3. So I end up with y equals negative, that's going to be 1/3 x minus 4. Okay? Then the other one, I'll kind of write it on the side here. So this one is here. This one is here. Okay? So I have 5x minus 3y equals negative 6. I need to get this by itself. So I'm going to minus 5x on both sides. That leaves me with negative 3y, a minus 5x, and a minus 6. I'm going to divide every single thing by negative 3. And y equals 5/3 x plus 2. Okay? So, same thing. My m here is negative 1/3. My b is -4. My m here is 5/3. My b is +2. Doesn't matter which one you plot first. I'm going to do this one. So I'm going to plot it at -4. I'm going to go down 1 box, right 3 boxes. I don't think that it's going to work, that they're going to intersect there. So I'm also going to go up 1 box and left 1, 2, 3 boxes. Just to make sure. Okay. Then I'm going to plot my +2. I can't even go up 5. I'll be off. 1, 2, 3, 4, 5, 1, 2. But I can go the opposite way. 1, 2, 3, 4, 5. 1, 2, 3. So my point of intersection is at -3, -3. Okay? Let's plot one more. I'm going to do -2x minus y equals +1. So this one's going to be right here. The inverse of -2x is +2x. There is an invisible 1 in between the negative and the y, so I'm going to divide by -1 to every term, leaving me with a positive y, a -2x, and a -1. Okay? This one I'm going to put down here. Sorry, just because I know I'm probably running out on time. I have -6x equals 3y plus 3 minus 3 on both sides. 3y divide by 3, and y equals, I'm going to flip directions, -2x minus 1. Oh, this makes it easy. M is -2, b is -1, -2/1, sorry. And so both of these graphs are going to be at -1, and we are going to go down 2, right 1, down 2, right 1, and this is actually going to be both of these graphs. So this one is actually infinite solutions. Infinite solutions.